I'm a savage. Yeah. Classy, bougie, ratchet. Sassy, moody, nasty. Hacking, stupid. What's happening? What's happening? I'm a savage. Yeah. Hey, so you. Okay, so continuing with that TikTok theme, let's go ahead and get started. Today we are doing questions, nope, not 1 through 10. Nope, we're starting with 11, so that's already wrong. Okay, we are doing 11 through 20, I believe. Okay, so let's go ahead and get started with question 11. Okay, it says complete the table to represent a function. Remember, the most important thing that we need to remember y, and I'm going to go ahead and start with our y and then fill in our chart. It says explain why it is a function. For every y value, there is exactly one x value. And what that means is x doesn't repeat. Okay, so we'll do 0, 1, 2, 3, and 1, 2, 3, 4. There's your function. You have exactly one x value for every y value. Obviously, your chart did not have to look exactly like mine, but your explanation should have been like mine. Which of the following sequences maintains congruency of a figure? Remember, congruent means the same size, exactly the same. So it says a reflection followed by a rotation. That would keep it the same size. A translation followed by dilation. Remember, dilation changes size. Dilation either goes smaller or bigger. Bigger. Okay, so that's not going to work. A dilation, again, dilation does not work. A translation followed by dilation. Again, dilation. Dilation does not work. Dilation does not make a congruent figure. Okay, so if you see this word congruency, it is not going to be dilated. Okay, let's move on to the next one. Graph the following image after a translation of 8 units to the right and a reflection over the x-axis. Okay, remember translating just means we're sliding it. Okay, so it wants to be slid 8 units to the right. So I'm going to start with this point here in the corner, and I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8. That is going to be there. And then this other one is 1, 2, 3, 4 away from that. 1, 2, 3, 4. Is that right? That's not right. 1, 2, 3. Sorry. 1, 2, 3. Let me start over. Sorry. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. This is the far right corner, and then the other one is 3 away from that. So 1, 2, 3. That looks better. Okay, and then this one is 2 up from this. This one is 1 in, and then 1, 2, 3, and then here. Okay, we are not done. This is just our translated shape. We still have to reflect it over the x-axis. And this right here is our x-axis. So I'm going to use a different color. Okay, and if we are reflecting this over the x-axis, this point is 1, 2, 3 above the x-axis. So we're going to go 1, 2, 3 below the x-axis. And this one is 2 above that, so we're going to go 2 below that. And 1 in. And then this is 1, 2, 3. Yep. So we want to go 1, 2, 3. And this one is 2 over. And this one in the corner here. This is our final translated shape. Sorry, I'm a little sloppy when I'm drawing my lines on this thing. Okay. Number 14, Tidewater Beach Rentals rents condos for a total cost C as shown in the table below. So here's our table. Part A says write an equation that represents the function. Well, anytime we go to write an equation, what we need to start by doing is seeing how much we go from here to here, here to here, here to here, and do the same on this side. Okay, so we're seeing on this side it's easy. We're adding 2, right? The other side isn't as easy to do in our heads. We could do it manually by writing it on a sheet of paper. But if we are given the use of a calculator, that would make this a lot easier. So we're going to take 685 and subtract 295 and see what we get. We get 390. I'm going to do that with 1075 and subtract 685 from that just to make sure we're continuing to get 390. And then again with our last one, just to triple check, 1465 minus 1075 again gives us 390. So that worked out. Okay, so now what we do is we take this, our change in y, and put it over our change in x. 390 divided by 2, and that gives us, divided by 2, 195. So that is actually going to be our slope. So we have C is our total cost. We're going to put our 195 as our slope. We're going to put that next to D for days. And then we're going to see if that works out. It may work out, it may not. It's not going to work out for this problem. But here's how we solve that, or how we see if it works. We take our 195 and then we plug in our days and see if it equals our total cost. So 195 times 1, does that give me 295? No, it does not. I need to add something to that to get the 295. Well, 195 plus 100 gives me 295, so we are going to add 100 to our rule. And that's our equation. C equals 195 times D plus 100. What is the rate of change in the function? Rate of change is just another word for slope. So our slope is the number that is in front of D, and that is going to be 195. What is the initial value of the function? Our initial value is just our y-intercept, and that is going to be what we add or subtract here out to the side, so that's going to be 100. Okay, number 15, it says the mass of a pencil. The mass of a pencil is approximately 5 times 10 to the negative first grams. The mass of a package of notebook paper weighs about 2.5 times 10 to the second grams. About how many times greater is the mass of the package of notebook paper than the mass of the pencil? So if we're finding out how many times greater something is than something else, we're dividing. So we're going to take 2.5 times 10 to the second grams, and we're going to divide that by 5 times 10 to the negative first grams. When we are dividing exponents with the same base, what we're actually doing is subtracting them. So what we're going to be doing is subtracting 2 minus a negative 1. And 2 minus a negative 1 is actually 2 plus 1, which equals 3. So our 10 is going to go to the third power. And then we're really just dividing here. 2.5 divided by 5. Again, you can use your calculator, but you could do this in your head. You know that 25 divided by 5 is 5. So 2.5 divided by 5 is 0.5. So we have 0.5 out here, and then we're going to be multiplying them together. So again, we want to put our answer back into standard form. So if we've got 0.5 times 10 to the third power, okay, I don't know what that is, sorry, we are moving our decimal 3 times to the right because it is a positive exponent. So 1, 2, and 3, we're going to put zeros in our empty buckets. We do not need the 0 out in front of the 5 anymore, so our answer is 500, or 0.5 times 10 to the third power. Okay, it says determine if the following are rational or irrational. Remember, if it is not something that you know automatically off the top of your head, it is probably irrational. I do not know the square root of 8 off the top of my head, so that's going to be irrational. 3 over 9 is just 1/3. That is rational. 2 to the 5th.
sorry, 2/5 is rational. That is just a fraction. And 35, the square root of 35, I don't know that off the top of my head either, so that is going to be irrational as well. My checks are not backwards to me, by the way. Everybody says my checks are backwards, but I'm left-handed, so this is correct to me. All right. This says evaluate. Express your answer in scientific notation. So we have 6 times 10 to the 6th power plus 2 times 10 to the 6th power divided by 4 times 10 to the 2nd. So I first want to take care of this top row here. And 6 times 10 to the 6th power is 6 with 6 zeros. And 2 times 10 to the 6th power is 2 with 6 zeros. And we're just adding those together. So 6 million plus 2 million gives me 8 million. Okay, and if we wanted to change that back into scientific notation so that we can divide it by 4 times 10 to the 2nd, we could move our 0 1, 2, 3, 4, 5, 6 times to the left. So that would be 8 times 10 to the 6th power. Notice that our 10 to the 6th power did not change. When we have exponents with the same base, you really can just add your numbers out in front. So 6 plus 2 gives me 8. That would have been an easy way to do this. But I wanted to show you that we can move our decimal points and add them manually because you may not always have exponents with the same base that you're working with. So then we have divided by 4 times 10 to the 2nd power. Okay, 8 divided by 4 is 2. And then 6 minus 2, because when we have exponents with the same base and we're dividing them, we subtract our exponents. So 6 minus 2 gives me 4. So it would be 2 times 10 to the 4th power. And it did say keep your answer in scientific notation. So that's going to be our answer. Okay, it says a trapezoid is shown. Draw the trapezoid after a translation. Remember, translation is just a slide of 2 units to the right and 2 units up, followed by a reflection over the x-axis. So 2 units to the right and 2 units up. So this point is going to go 1, 2 units to the right and 1, 2 units up. And then it's going to be reflected over the x-axis. I'm going to move all of my points first and then reflect it over the x-axis. This point, 2 units to the right and 2 units up, 2 units to the right and 2 units up, 2 units to the right and 2 units up. So this is my trapezoid, and then we are reflecting it still over the x-axis. So I'm going to get a different color so we can see the difference. If this is 2 below the x-axis, we want to go 2 above the x-axis. This one is here and then 6 above the x-axis because right now this one is 6 below. It's at -1, -6, so we want to go -1, +6. This is 2 below, so we want to go 2 above. And then this is also +6, but it is at -7. So we want to go to -7 and then up to +6 and put a dot. Best of good. Okay, so that is our final translated version of our trapezoid. Translated and reflected, I guess. Okay, so write 6/8 as a decimal. When we are dividing, fractions are just division problems. I can't talk. Fractions are just division problems, so we're going to put the top number in the house and divide it by the bottom number. Of course, if you were given a calculator on this one, you could just put it into your calculator, but we are going to do this manually. 8 cannot go into 6. But we're going to put a decimal, annex a 0. 8 goes into 67 times. 7 times 8 is 56. Subtract and we get 4. You could borrow here. Okay, so then we annex another 0, bring it down. 8 goes into 45 times. 5 times 8 is 40. Subtract and we get 0. So our answer is 75 hundredths. Okay, so it says solve for y. Y to the 3rd power equals 27 thousandths. So y to the 3rd power Y to the third power is simply y times y times y. So we need to figure out what number, when multiplied by itself 3 times, gives us 27 thousandths. Sorry. So if we can think about, let's take away the thousandths right now. Let's look at the number 27. What 3 numbers can be multiplied by itself to give us 27? Well, that number is 3, because 3 times 3 gives us 9, and then 9 times 3 gives us 27. So we want 27 thousandths. So we actually need some decimals here. So 3 tenths times 3 tenths times 3 tenths gives us 27 thousandths, because we have 1, 2, 3 decimal places, and we have 1, 2, 3 decimal places here. So our number is actually going to be 3 tenths. Okay, that's all I have for you guys today. I miss you guys. I hope you guys are doing really great. I hope you are keeping social distance from your friends. Remember, you can FaceTime and use social media to get in touch with them. I hope you are enjoying time with your family right now, and I hope you are all staying safe. I miss you guys. See ya.